Hello, this is Dr. Montgomery, and I'm going to do my best to capture some lecture for you on the unit we're working on, which is the kinetics of chemical reactions. So we already discussed determining the rates of reactions from the initial rate method, and you guys have done some homework on that subject, so hopefully you're doing well with that. We're next going to talk about graphical analysis techniques. So the trick here is to plot the change in concentration of one of the participants in the reaction as a function of time in two different ways. We'll either plot it as the natural log of the concentration data, in which case if we see a straight line decreasing as a function of time, then we can determine that the data are first order in the concentration of A. Or we can plot the data as the inverse, 1 over the concentration of A, as a function of time. And for that, we'll see an increasing linear dependence. So if you plot the data as 1 over the concentration of A, so you'll have a set of data that are concentration as a function of time, and you take the concentration and you manipulate it, just take the inverse of it, and you'll plot that data. And then if you see a graph such as this, linear dependence increasing, then you'll know that the order with respect to concentration, with respect to reactant A is second order. All right, so I'm going to pause here and go to an example of this. Okay, so let's say you have a set of data for the decomposition. Actually, this isn't a decomposition reaction. We're looking at a reaction. It's practice exercise at the bottom of page 657 of Gilbert 5th edition. And it's a reaction of nitrogen dioxide and carbon monoxide to produce nitrogen monoxide and carbon dioxide. And so we have some reaction data, and we have the concentration of the nitrogen dioxide as a function of time. So what we're going to do is take the data and enter it into an Excel spreadsheet here. And then we're going to manipulate it a little bit. So, all right, now that I have the data entered, I'm going to go ahead and graph it. So what I want is time on the x-axis and concentration on the y-axis. So I've got to set up correctly in Excel for this to work. And I'm just going to insert a scatter plot here. All right, so if we look at these data, we can tell they don't look linear, right? We don't have a linear trend here. We have some curvature in our data. So we will take first the natural log of the concentration of our NO2. Okay, and if you guys remember in Excel, this is super easy to do. You just take the function here, and Excel will calculate it for you. And then if you get this little bold crosshair on the bottom right corner of your cell, it copies and pastes it down. All right, so now instead of plotting the raw data, we're going to plot the natural log of the raw data. So let's change our y values here. We're going to edit this series. We're going to leave the x data alone. We're going to just change the y values from the original raw data to our natural log data. Okay. Then what we want to do is add a trend line. And we're going to see how linear this trend line looks. You can't see what I'm doing here. It's in the bottom right corner of my screen, so it's not displaying for you. But you're just going to display the r-squared value on the chart for your fit. And so this isn't a great fit. It's acceptable for certain things, but let's go ahead and take 1 over the data 1 over the concentration data, and see if we can get a better fit from that. So this is going to be equal to 1 divided by that data point in cell B2, and I'm going to copy it down like so. And now I'm going to plot a new chart. I'm just going to plot it right on top of the one that we were already looking at. I'm holding down the control key as I highlight these 2 columns of data. And here I'm going to insert a scatter chart. And you see this data looks a little bit more linear. I'm going to add a trend line. And I'm going to show that R-squared value on the chart. So this R-squared value is 0.9998, which is really close to 1, whereas the R-squared value for my natural log data was 0.9741. So these are the data with 1 over concentration, and they're more linear. So 1 over the concentration of NO2 gives me a linear trend. So what this means is that oops, sorry about that. I'm a little bit not used to using this program, so forgive me. Right now things are cut off. Hold on. Okay, so we have a better linear trend with the 1 over data, which means that the rate is second order in the concentration of the NO2.